Hi, in this video we're going to look at part 2 of Module 2, Section 1. We're going to discuss annuity notation. This is a very important section to get you used to annuity notation. You're going to see this through the rest of your actuarial career. Okay, so we've talked about this slide before. This is what's shown here is a basic level annuity. And now, when I put an arrow like that, as I mentioned in the last learning video, this is my valuation date. And so I'm going to label the value of this basic level annuity at this valuation date with this symbol, and I'm going to read that as an A angle N at rate I. So that's A angle N at rate I. The I, throughout the rest of this video, the I is going to represent the periodic effective interest rate where the period matches the period of the payment. So if you have annual payments, that I down there is going to be an annual effective interest rate. Always, through the rest of the video, that's what the I is going to represent here. Okay, so now I could describe this A angle N at rate I then as the value of a basic level annuity, one payment period before the first payment. So now, at the valuation date that's shown, the first period is going to be extending over what's shown, the time period that's shown there. And so the first payment is at the end of the first period. Likewise, the second payment would be at the end of the second period and so forth. And so I could describe this A angle N at rate I as the value of a basic level annuity immediate at the annuity start date. The first payment's at the end of the first period. That's going to make this an annuity immediate, and the annuity start date would be at the beginning of the first period. That's where the valuation date is, and so this is the value of a basic level annuity immediate at the annuity start date. And I'm going to simplify that to say this is the present value of a basic level annuity immediate. So now for the next several slides, I'm just going to move the valuation date and go through the same thought process and introduce the notation that goes along with each of the other valuation dates. So let's move the valuation date to here. In this case, I'm going to denote the value of the annuity at that valuation date with this symbol. It's read A double dot angle N at rate I. Once again, I is the periodic effective interest rate, matches the same period as the payments. I'm going to quit saying that because I'm going to have that at every one of these valuation dates. I'm going to say that same thing, or I'm going to have it written. I'm going to quit saying it. It's going to be implied now. Okay, so now how could I describe this A double dot angle N at rate I? It would be the value of a basic level annuity immediately before the first payment. Well, with that valuation date as it is, if I think of that as the start date, then the first period would extend as shown. So the first payment would be at the beginning of the first period. The first payment would be at the beginning of the first period, the second payment at the beginning of the second period, and so forth. And so this would be the value of a basic level annuity due at the annuity start date. Remember, an annuity due, the payments are at the beginning of each period. So the first payment, as shown, the first payment is at the beginning of the first period, and so forth. The start date is always at the beginning of the first period. That's the valuation date. So this would be the value of a basic level annuity due at the annuity start date. I'm going to simplify that to say it's the present value of a basic level annuity due. All right, same thing. Let's move the valuation date. Let's say the valuation date is here. The symbol that I'll use for the value is this, which is read S angle N at rate I. So S angle N at rate I, once again, I is the periodic EIR. Let me describe that in words. It would be the value of a basic level annuity immediately after the last payment. So now I'm going to think of that as the end date. And if that's the end date, the last period, the nth period, would end on that date. That would mean that the last payment is at the end of the last period. That would mean the first payment would be at the end of the first period. And so I could describe this S angle N as the value of a basic level annuity immediate at the annuity end date. And I'll simplify that to say it's the accumulated value of a basic level annuity immediate. And then finally, this is going to be the last valuation date. What if the valuation date is here? The symbol I'm going to use is going to be called an S double dot angle N at rate I. This time, I could describe it as the value of a basic level annuity, one payment period after the last payment. Once again, I'm going to think of that valuation date as the end date. So the nth period would end at that date. That would make the last payment at the beginning of the last period. Likewise, the first payment would be at the beginning of the first period. And so I'm going to think of this then as, or this could be thought of then as the value of a basic level annuity due at the annuity end date. And I would say that as, I would simplify that as the accumulated value of a basic level annuity due. Okay, so now let's look at some basic relationships between these symbols. So I've got this basic level annuity at this valuation date that's shown. The value of that basic level annuity, I would think of that as the present value of a basic level annuity immediate. I write that as an A angle N at rate I. A comment here that I'm going to I'm going to start using this notation is I'm going to start I'm not going to say the at I part. So the I, if there's no ambiguity in the problem, then the I is going to be understood to be there, and you'll see that symbol written without it. So look at the slide here. I don't have the symbol. The slide before, I have the symbol. I've got the symbol now. Oftentimes, and for the rest of this video, I'm not going to include the I. It's going to be understood to be there, though. Okay, so now that would be the present value of a basic level annuity immediate. If I move the valuation date up one period, I have an A double dot angle N. That's the present value of a basic level annuity due. Now, what's the relationship between these two values? Well, these are just values. These are single values, one period apart. So for instance, if I had the value A angle N and I wanted the value A double dot angle N, I would need to accumulate that value one period forward, and I would do that by multiplying by the periodic accumulation factor, which is a 1 plus I. And so that's a basic relationship between an A double dot angle N and an A angle N. If you have the value A angle N, I would multiply by 1 plus I to get the value A double dot angle N, because I'd have to accumulate it one period. On the other hand, if I knew the value of an A double dot angle N and I was seeking the value of an A angle N, well, I would need to discount the value A double dot angle N one period back to get to A angle N, and I do that by multiplying by a V. So these are kind of equivalent equations, these are equivalent to one another. So that's a basic relationship between an A double dot and an A. You just accumulate or discount depending on which you're doing. And of course, again, the I is the periodic effective interest rate, and the V here is the periodic discount factor. Okay, now let's look at different valuation dates. Instead of A's, let's look at S's. The S's were accumulated values or future values. And so I have an S angle N, and then I have an S double dot angle N. Well, what if I knew the value of S angle N and I was seeking the value of an S double dot angle N? I would need to accumulate that value one period forward. So the relationship there with the S double dot angle N would be an S angle N times a 1 plus I. Or equivalently, if I was turned it around and if I knew the value of an S double dot, then I would multiply that times V to get the value of an S angle N, where again, V is the periodic discount factor. In other words, V is 1 over a 1 plus I. Take the first equation and divide both sides by a 1 plus I, and you actually get the second equation. Okay, so now let's look at a couple other basic relationships here. Let's view this as, let's assume that the first period is as shown, and if the first period is as shown, the first payment ends at the first period, the nth payment would end at the nth period, so I'd put in a picture that looks like this. I'm thinking then of this annuity as being an annuity immediate. The payments are at the end of each period. And so at the start date, I have the present value. The A angle N is the present value of the annuity immediate. And at the end date, I have an S angle N. That's the accumulated value of an annuity immediate. And the point here is that there are end periods between the valuation date where I have the symbol A angle N and the valuation date where I have the symbol S angle N. So if I knew the value of an A angle N and I was seeking the value of an S angle N, all I need to do is accumulate that A angle N for N periods, and I would do that by multiplying by a 1 plus I to the N. So I get this, the basic relationship that S angle N is an A angle N times a 1 plus I to the N. And then again, turn it around, multiply both sides by a V to the N, which is a 1 over a 1 plus I to the N, and you solve it the other direction, that if I knew the value of an S angle N and I was seeking the value of an A angle N, I would need to discount it for N periods, and I do that by multiplying by a V to the N, where V is the periodic discount factor. Okay, last comment is I was I was showing you relationships between the A and the S based on the first and the last period being here. What if the first and the last periods were shifted so that now I'm viewing this annuity as an annuity due? You see, the first payment is at the beginning of the first period. The last payment is at the beginning of the last period. Payments are at the beginning of the period. Now I'm viewing these annuities as an annuity due. The start date, the end date would be shown here. And the A double dot angle N would be the present value of this basic level annuity due. The S double dot angle N would be the accumulated value of this basic level annuity due. But once again, there are N periods between those valuation dates. And so if I had the value of an A double dot angle N and I was seeking the value of an S double dot angle N, I would multiply by A double dot angle N by 1 plus I to the N, because that's how I'm going to accumulate it. And then, reverse in the reverse direction. If I knew the value of an S double dot angle N, I would need to discount that in periods to get an A double dot angle N. And again, so I is the periodic effective interest rate and V is the periodic discount factor. Okay, so as a summary, these are the 4 valuation dates that are going to be important when I see an annuity. I can view these if I'm just given a general annuity, and sometimes I have I can view it either as an annuity immediate or an annuity due. But these are the valuation dates that are going to give you present values of an annuity immediate, present value of an annuity due, accumulated value of an annuity immediate, and accumulated value of an annuity due. Notice that I have the I's on the symbols here. So for instance, the first symbol, A angle N at rate I. But as I mentioned it earlier in the video, oftentimes we'll leave the I's off if there's no ambiguity. If there's no confusion, we'll just leave the I's off. Okay, so be sure that you understand these symbols and what they mean and where they value the annuities. So it's going to be very important for the rest of the semester or the rest of the course. All right, I'll see you in the next video.